Okay, this is the combination and permutations worksheet. You're going to need a calculator. Your phone calculator may or may not work for this. Um, and there are some fancy buttons on the scientific or graphing calculators that will help. You can do it the long way, but nobody in this world actually does. So, at the beginning, suppose that a student has 5 textbooks labeled 1 through 5 for school. If her backpack can only hold 2 books, how many different ways can she fill her backpack? Well, let's write that out. What could happen? What What's the sample space? We could bring book 1 and book 2, or 1 3, 1 4, 1 5, 2. What about 2 1? That's the same thing. If your chemistry book goes in before your history book, is that any different? No, it's not. So 2 1 is not a possibility. 2 3, 2 4, 2 5, 3 4, 3 5, 4 5. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 possibilities. And we learned something here. We learned that 21 is equal to 12. Bringing book 1 and book 2 is exactly the same thing as bringing book 2 and book 1. Does that make sense? So the number 21 and the number 22 are the same number. No, that's not what I meant. Sorry. What we say here is order does not matter. The order you put the books in the backpack has no bearing on this situation. Okay. Um, what about the number 44? We don't have 2 chemistry books. So 44 doesn't exist in this instance. Okay. All right, the next one. If 5 marbles are in a bag labeled 1 through 5, how many different ways can you pull out 2 marbles and arrange them to create 2-digit numbers? So what would that look like? 1 2, 1 3, 1 4, 1 5, 2, 2 1. How come? It's a 2-digit number, right? This is just a situation describing which books come to school with us. But is the number 12 equal to the number 21? No, they're not the same number in this case. So 21, 20, what about 22? There are not 2 2s. No 2 2s here. So 2 3, 2 4, 2 5, 2 6. No, there's no 6. And then 3 1, 3 2, 3 4, 3 5, 4 1, 4 2, 4 3, skip 4 4, 4 5, 5 1, 5 2, 5 3, 5 4. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this had 10 possibilities. This has 20 possibilities. Right? Um, did I miss anything? Um, So in this case, 21 is not equal to 12. And what we say is order does not, order does matter. So do you see the difference in these two situations? If I just bring 2 books to school, that's different than putting one book on a bookshelf first and another book on the bookshelf second. Okay, there's an order to that. All right, number 3. If there are 5 marbles in a bag, like, oh yeah, yeah. Don't worry about it. If you haven't done it, then yes, you should write it down, but don't catch up. Okay, everybody clear? Sorry. Maybe just write this stuff down if you haven't done it already. I'll give you a second. Now on to the third problem. If there are 5 marbles in a bag, labeled 1 through 5, how many two-digit numbers can be created using the following method? Reach into the bag, take out a marble, write down the number on a piece of paper, put the marble back in the bag, draw a second marble, write down the number. What is that going to look like? Yeah, what's the very first possibility in this case? 1, 1. How come? We put the marbles back in the bag. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, 4, 4, and 4, 5, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. How many possibilities? 25. So over here, is 12 equal to 21? No. Those are 2 different numbers, right? Okay. And in this case, 11 does not exist. And in this case, 11 exists. These are the 3 different possibilities, and we're going to give them names. Okay? So, down in on the box in the middle of the page, the first one is combination. So this is a combination. So what do I want you to write in that definition? I want you to write 12 is equal to 21 and order does not matter. So the definition of a combination is 12 is equal to 21. Nope, doesn't matter. And order does not matter. Okay? And then we're going to give you a couple more definitions. We're going to give you the definition of n. That is the number of marbles in the bag. Or in this case, the number of books. So n is the number of marbles in the bag. And r is the number of marbles chosen. So our variable n is the number of marbles in the bag, and r is the number of marbles chosen. Okay, so how do we calculate a combination? Well, the formula is kind of weird. All that stuff. I broke it. No, I didn't. Oh boy, yes I did. Okay, so here is the formula. Let's go to a new page. So a combination formula is n factorial over r factorial times n minus r factorial. Okay. What does factorial mean? You multiply that number and all of the integers smaller than that, well, all the natural numbers smaller than that. So what is 8 factorial? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So in the story that we just did, what is our n? How many books were there? 5. And how many books were chosen? 2. So what would this formula be? 5 factorial over 2 factorial times 5 minus 2 factorial, which is 3 factorial. Okay, now don't write this out. Just watch. 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. And then we just cancel a whole bunch of things out. So that cancels that, that cancels that, that cancels that, and that turns this into a 2. The bottom is all gone, which is always going to happen. And the top just becomes 10. That number looks familiar. That was our answer, right? Now, nobody in their right mind is going to do that. Okay? We have a special button for that. It is called the NCR button. Now, whether you have a small calculator or a big calculator, it's going to be in what's called the probability section. So if you are using the small blue calculators, probability, go to the top left, down 1, right 1. Okay? If you have a graphing calculator, I'll show you where it is, but in either case, you have to do 5 and then push this NCR button and then 2. So if you look on mine, I'm going to push the number 5, and then I go into math, and then I go over to probability. So over here to probability. Oh, that was dumb. 5 math, go to probability, NCR 2. So your probability button is right there. 5, and then push probability, and then go over to NCR, and you'll see the factorial button on there. You did it the hard way? I'm sorry. Oh. Okay. So do you have a different kind? So maybe you push it twice. Yeah. Okay. Now, in the mathematics world, nobody actually writes 5C2. Okay? So nobody ever uses this formula except you really rambunctious people who worked ahead and already did the assignment. I'm sorry. That'll teach you for working so hard. So nobody uses that formula. Okay? Everybody uses this. But that's not how anybody actually writes it. We write it like this. And we say 5 choose 2. When we say 5 choose 2, that tells you it's a combination where there are 5 books and 2 books are coming to school. Okay, can you remember that? 5 choose 2. And you can calculate that using your NCR button. All right, that's a combination. So everybody type in 5 choose 0. The first one on combination. So 5 choose 0. What do you get? So 5 choose 0 is 1. What does that mean? And don't work ahead. Don't work ahead. Don't work ahead. Don't work ahead. What does 5 choose 0 mean in our book story? You don't take any books to school. How many ways are there if you have 5 books to take none of them to school? 1. That's kind of weird, right? Okay. Again, don't work ahead. Okay. So let's think about it. What is 5 choose 1 going to be? If you have 5 books, it's going to be 5. Try it. 5 choose 1. What do you get? Yeah, write them down. Is 5. And that makes sense. If your backpack only holds 1 book, this used to make a lot more sense when we carried books to school, but maybe I should update my worksheet. So 5 choose 1 is, how many ways can you bring 1 book to school? 5. You can bring 1 or 2 or 3 or 4 or 5. Okay, we already know 5 choose 2. And again, don't work ahead. 5 choose 2 was 10. Okay, guess. What is 5 choose 3 going to be? 15? I said don't do it. Good job. So 5 choose 3 is also 10. What's going on here? There is a pattern. Good. Now, don't work ahead. You naughty. 5 choose 4. What do you think it's going to be? 20? 12? Try it. See what happens. It's 5. So 5 choose 4 is 5? Can anybody make sense of that? Mm-hmm. Mm-hmm. That is true. That is actually not a combination, but you're onto something. Oh, that's the trick. If you bring 4 books to school, that's kind of a pain to write out, right? 1, 2, 3, 4, 1, 2, 3, 5, 2, 3, 4, 1. Like that's a pain to write out. But if you bring 4 books to school, how many did you leave home? 1. So why are these the same? Bringing 2 is exactly the same as leaving 2. It's just easier to write down. Okay? So, what about 5 choose 5? 1. Why? You're bringing all of them. So 5 choose 5 is 1. Every single combination situation will look just like this. Bringing 4 books is the same as bringing 1 book because you're dividing them into coming to school and not coming to school. All right? Okay. Permutations. There are 2 types of permutations. And in both types, so write this down in the definition, a permutation is 21 is not equal to 12, which means order matters. So it's like saying, if you bring your physics and your chemistry book, is that different than bringing your chemistry book and your physics book? No, it's the same thing. Does it matter which one goes in the backpack first? No, it doesn't matter. They're the same number. Okay? That would be a combination, sorry. This is a permutation. So in this case, if this was like your phone number, does order matter in your phone number? Oh, yeah. If I just said, my phone number has 3 4s, 2 7s, and 5 1s, is that enough? No, you're going to be calling somebody, not me, probably. So in that case, order matters. The spelling of your name, does order matter? Yeah. If I told you 3 people in this class are getting an A, does order matter? No, order doesn't matter. If I said you, and you are getting an A, is that different than you, and you? No, you're all getting an A. Okay. All right, so order matters. And another thing about this permutation is 11, that's a 10, 11 does not exist. This is called a permutation without replacement. So if 11 does not exist, that means you pull a marble out, you set it down, you reach in the bag, you pull out another marble and set it down. You don't stick it back in between draws. Okay? Well, what does that formula look like? So the permutation formula is n factorial over n minus r factorial. That's really similar. Right? The only difference is the combination formula had an r factorial here. So which one's going to be larger? Combinations or permutations? Permutations. Why? We're leaving out some of the numbers in the denominator. Okay. So this situation would be 5 factorial over 3 factorial. So 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Cancel, cancel, cancel. And I get 20. Now, nobody in their right mind, other than you poor people who worked ahead, are going to use this formula. Okay? Instead, we're going to do the 5p2 formula. So try that in your calculator. So 5 math probability 5p2. We get 20. Now again, don't work ahead. 5p2 is 20. Now, most people do not use this button on their calculator. I never do. Okay? Why is that? Well, there's a more intuitive way in my mind. Okay? So my n is 5. That's the number of options I have to choose from. And my r is 2. That's the number of items I'm going to select. So what you can do is write out r spaces. So I can write out a problem that has r spaces. And then I just multiply. How many options are there for digit number 1? So this has n possibilities, right? My first number could be a 1, a 2, a 3, a 4, or a 5. So there are 5 of them. Times, how many possibilities are there in my second number? 4. Why 4, Jaden? I already used one of my numbers. Does everybody see that? So I reach in the bag, I pull out a 3. Well, sorry. I reach in the bag. What could come out of the bag? A 1, 2, 3, 4, or 5. So there are 5 choices. I pick the 3. I leave it out. Now, when I reach in the bag again, how many marbles are in the bag? There are only 4. So I could pull out like a 2. So the first digit has 5 possibilities. The second digit only has 4, and that's where my 20 comes from. Okay? So, don't calculate this. What is 5p0? So, if I have 5 marbles in the bag, how many ways are there to write a 0-digit number? Try it. 5p0. What do you get? 1. How do you do it? You leave all the marbles in the bag. Does that make sense? How many ways are there to pull no marbles out of the bag? 1. You don't do anything. Okay. Now don't calculate it. What about 5p1? That is a 1-digit number. 5. So 5p1 is 5. Okay. And we already know 5p2 is 20. Don't calculate it. What do you think 5p3 is going to be? So here's the question. Are there more 2-digit numbers or 3-digit numbers? So let's go back here. Here are all of my 2-digit numbers. What if I extended them to 3-digit numbers? Are there going to be more or less? Fewer? More. Because this could be a 3, a 4, or a 5, right? And this could be a 2, a 4, or a 5. So I have way more numbers. So let's calculate it. What is 5p3? What do you get? 60. Okay. What about 5p4? Is it going to go up or down or stay the same? Up. So try it. What is 5p4? 120. Don't go ahead. Okay. What about 5p5? Did you cheat again? Oh, that was your first time cheating. What is it? Try it. 120. What? Why would that be 120? So here's the question. Are there more 4-digit numbers or 5-digit numbers? There's the same. So, okay, let's play this game for a minute. Let's pull out 4 marbles. So I reach in and I pull out the 1, the 5, the 4, and the 2. The last one is a 3. Do you guys see that? So if this one has to be a 3. So what if I pulled out 2, 3, 1, 5? The last one has a 4. So if I listed all of these, how many are there? 120. If I put that remaining number on the end of every one of them, how many are there? Still 120. So your second to last choice determines your last choice, whether or not you pick it. Does that make sense? Some of you, that's not going to make sense, and then I'll show you the formula, and it's going to make a ton of sense. Okay? How many ways are there to make a 0-digit number? 1. Okay? If I have a 1-digit number, how many ways are there to fill that spot? 5. Everybody follow? What about a 2-digit number? Well, this spot has 5, and I've already used 1 marble, so this spot has 4. And 5 times 4 is 20. What about a 3-digit number? Well, after I pick this marble, and I pick this marble, how many marbles are left in the bag? 3 of them. Okay? All right. What about 4 marbles? 4-digit number. 2. And what about a 5-digit number? 1. Does that make sense? So there are 5 ways to pick 1 marble out of the bag. There are 20 ways to pick 2 marbles out of the bag. There are 60 ways to pick 3 marbles out of the bag. There are 120 ways to take 4 of them out of the bag, and whether or not you use that last marble is not going to change the situation. Okay? So there are just as many ways to line you guys up in a row if I line up all of you or if I leave one person out. So in a permutation, this will always be the same. The last 2 will always be the same. Okay? All right. So let's go here. With replacement. What does that mean? What's the definition of with replacement? 11 exists. Okay. Now, if you go into your probability folder in your calculator, there's no other button. We have a combination button. We have a permutation button, which only covers without replacement. But there's no button for permutation with replacement. So the only way to do it is to line up your possibilities. So how many ways are there to make a 0-digit number if you put the marbles back in the bag? 1. You don't do anything. Okay. What about 1 digit? How many ways are there to build a 1-digit number if you have 5 marbles? 5. Okay. All right. What about 2 digits? Well, we already did 2 digits in the third problem up top. We wrote them all out, right? How many are there? 25. But I'm lazy and I don't want to write them out every time. So how do we figure that out? Well, we just use the permutation system. How many options are there for digit 2? 5. Why? I put it back in. So I reach into the bag that has 5 marbles. I pull one out, I write down the number, and I stick it back in. I reach in a second time, pull out a marble, write down its number. So digit 1 has 5 possibilities. Digit 2 also has 5 possibilities for a total of 25. Then let's say multiply, but yes. So what about the next one? Another 5. So 5 times 5 times 5 is 125. What about a 4-digit number? That is 5 to the 4th, which is 625. And the next one, what do you think? No, they're not going to be the same. Good. So what is 5 to the 5th? I don't remember. 3125. 3125. Could I build a 6-digit number in this case? So I could build a 1-digit number. I could build a 2-digit number. I could build a 3 or a 4 or a 5-digit number. Could I keep going and build a bigger number? How long can this number be? It keeps going forever. As many times as you're willing to reach into that bag, that's how long the number is. Okay, let's go here. In that middle one, permutation without replacement, can I build a 6-digit number? No, I can't. So let's ask the calculator. What is 5p6? 5p6. 0. That's kind of weird, right? There aren't 6 marbles, right? So we've broken it. So how many ways are there to make a 0-digit number? 1. What do? You do nothing. How many ways are there to build a 6-digit number? You can't, which is kind of weird. There is one way to build a 0-digit number. You don't do anything. There are 0 ways to build a 6-digit number because you don't have that many marbles. 7C6, 7 choose 6 would work. So R has to be less than or equal to N. Okay. What about combinations? What about 5 choose 6? What would that mean in our story? So you have 5 books at home ready to come to school, and you're going to bring 6 of them to school. How many ways can you do that? So if you try it, 5C6, you get 0. So there is one way to bring no books to school. You just don't do anything. But there are 0 ways to bring 6 books to school because you don't have that many. Okay? So, in review, if 12 is equal to 21, let's say we have 8 books and we're bringing 3 to school. Okay? If 12 is equal to 21, then you do 8C3. Okay? If 12 is not equal to 21, this would be line up books on a shelf. If you are putting books on a shelf, is book 1 and then book 2 different than book 2 and then book 1? Yes. If you don't believe me, go in the library and rearrange them and see if anybody gets upset. Does that make sense? So if you check out 3 books today, does the order matter? No. But if you line them up on a shelf, does the order matter? Yes. So in this case, you could do 8P3, but nobody does that. Instead, I line up 3 spaces. How many options are there for book number 1? 8. How about book number 2? 7. Book number 3? 6. 8 times 7 times 6. Or you could do 8 factorial over 3 factorial times 5 factorial. But yeah, I wouldn't do it that way. Okay. What if we have 8 digits, 8 numbers, and we're building an area code? Does 12 equal 21 on an area code? No. 435 is different than 345. Okay. How is this different from this? So in this one, 11 does not exist. And in this one, 11 exists. So both of these are permutations. And when you're calculating a permutation, you just write it out like this. How many options are there for digit 1? 8. How many options are there for digit 2? 8. And digit 3? 8. So that's how you calculate them. If it's a combination, use this button. If it's a permutation, you just line them up, and you just have to decide, does 8 have a possibility of being chosen twice? Okay. So you have, well, I don't care. But the button will only work here. It won't work here. I don't care if you use the formula, but I might make fun of you. That's fine. All right. So you have 15 problems to do. All of the answers are on the back. So I would answer it first and then check it. And then if you get confused, let me know and I'll come help you. Go for it.